Hey guys, Mr. Gucci here with your first homework help video. Okay, I'm going to make a few of these to get you through the 11.2 worksheet, warming and melting solids. This first video is going to be problems 1 through 6, where I'm going to do a few of them to sample to you and then leave the rest up to you. Okay, here we go. Again, this is 1 through 6. Now, the first step in this worksheet always is put your name. My name is David G. And the next step is to put your student ID. 1, 2, 3, 4, 5, 6. Yours, of course, will be different. All right, you have a different student ID. So now we get to the first problem. Let's see, I got to move some of this crap out of the way. Here we go, minimize that. Okay, cool. So the first problem. A 5,630 gram iron pan is placed on the stove, and after a few minutes, its temperature is increased by 453.5 degrees Celsius. How much heat energy in joules did the pan absorb? Okay, now we only have one equation that we're doing for these first 6 homework problems, and the equation is right here. Okay, here is the equation. The equation is Q equals M times C times delta T. All right, Q right here, this is the energy for a temperature change, and it's measured in joules. Okay, next we've got M, which is the mass. All right, that is how much an object weighs, measured in grams. Now, real quick, I'm going to skip over here to the end. Over here, T is the temperature change. All right, not the starting temperature or the ending temperature, but how much the temperature changes. And we measure that in degrees Celsius. Lastly, we have got, let's make this bright pink, hot pink. We have got C, which is the specific heat. All right, and the unit for this, it's kind of weird, joules per gram degree Celsius. All right, by the way, the specific heat, you will almost always look this up. This will be given to you. This is a value that is a constant based on the specific substance that you are dealing with. Okay, so this is the formula we'll be using for this entire first 6 homework questions. So let's get to it. Q equals M times C times delta T. So problem number 1. All right, I'm going to start with Q equals M times the mass times the specific heat times the change in temperature. Now let me go back and let's look at this problem. Okay, so I am writing this stuff down as I go. You can do the work in this column right here, or you can do it on a separate sheet. So a 5,630 gram iron pan. So check that again. 5,630 grams. I'm going to have to plug that into the equation, and that is the mass, because the mass is what's measured in grams. So the mass is 5,630 grams, okay? Let's see what else they give us in this problem, okay? They tell us that the temperature increased by 453 degrees Celsius. That's the temperature increase. That is the change in temperature. So the temperature increased by, and I have a really bad memory, so I have to write this down on paper in front of me, 453.5 degrees Celsius. Okay, so that's the temperature change. The temperature change is 453.5 degrees Celsius. Okay, and lastly, the specific heat. We need to find the specific heat, that specific value that tells us what effect energy has on a particular substance. Now, if I go back and look here, I don't see a number. I don't see a third number here listed for the specific heat, but you don't need it, guys, because I tell you that the pan is made of iron. It is an iron pan. That is what it is made of. And so because we know it is iron, we can go over here, and I have included the list of specific heats for different substances. All right, and we see right here, oh, here's iron. Iron has a specific heat of 0.45, all right? 0.45. So it's going to be, change the color here, all right, 0.45 joules per gram degree Celsius, okay? And we are looking to solve for the energy. All right, we're looking to solve for the energy. That's what the question wants. It wants the energy in joules. Well, folks, the energy in joules is just all these things multiplied together, okay? It's just the mass times the specific heat times the change in temperature.
Good morning, Abington Senior High School.
Sorry, I had to pause that. Okay, so guys, we just multiply all these things together, and I plug it into my calculator. 5,630 times the specific heat of 0.45 times the temperature change of 453.5, and I get as my answer, and it's a big answer, guys. These energy questions are often going to give you big answers. 1148,942, okay, or approximately 1,148,942 joules, okay, and that's because this is a large piece of iron, and you're increasing its temperature by a lot, so it makes sense that this is a large number, all right, 1,148,942 joules. So I'm going to go over here and I'm going to plug that into my answer sheet and I'm going to see how it goes. This might be easier for you to do on a separate sheet, but if you think you can type this up effectively, guys, go for it, okay? 1,148,942. Hey, correct. That's the number of joules, okay? So there we go. So that's how you do this. You write down the equation, you plug in the values that you are given, and you solve for the unknown. For a few of these, the unknown is going to be the joules, all right? You're just multiplying everything together. But of course, guys, you've taken Algebra 1, all right? You know how to do some basic algebra. So it might not always be the energy you're solving for. Maybe I give you the energy and I ask you, hey, what's the change in temperature? Or maybe I give you the energy and the change in temperature, and I'm like, hey, how large? What is the mass of this object, right? You can solve for these things, guys. It's just algebra. Okay, let me try number 2. All right, let's try number 2. A 70.9 gram block of super chilled ice is placed in the microwave. You turn it on, and a few minutes later find its temperature has gone up 41.2 degrees Celsius. How much heat energy in joules did the block absorb? So I'm going to just write this stuff down. The mass is 70.9 grams, because grams is the mass. Okay. The change in temperature is 41.2 degrees Celsius, because it says that's how much the temperature has gone up. And what else do we know? All right, it's asking, we have to find the heat energy, so we're going to have to find the heat energy. All right, and it tells us, let's see, let's plug in what we can find so far. Okay, so here we go. I always start with the equation, guys. Q equals the mass, all right? So Q is the amount of heat energy is equal to the mass times the specific heating value for the substance times the change in temperature. So right off the bat, we are given the mass, all right? We know the mass. Let's see here. Right off the bat, we know the mass. The mass is 70.9 grams. We know this because it says it. It's the mass, and it's measured in grams, okay? We also know the change in temperature. It said that it went up 41. Let me change that thickness a bit. All right, cool. It said that it went up 41.2 degrees Celsius. Okay. Now we have to find the energy, all right? The energy is what it wants. So we're looking for Q. It didn't give us a number for C, but it tells us that the substance in question is ice, all right? Ice is what this thing is made of. So I can look up the specific heat over here. The specific heat of ice is 2.04. 2.04 joules per gram degree Celsius. And once again, folks, I'm just going to multiply all of this stuff together, all right? To find the energy in joules, it is going to be 70.9 times 2.04 times 41.2. And I get as my answer, I get 59.59 joules. 59.59 joules. This is a much smaller number. Oh, sorry, not 59.59, 59.59, all right? Still a much smaller number than above because we had a much lower mass, all right? And we were changing it by a much lower temperature, okay? So a lot less energy. So 59.59 joules, let's see if that's correct, okay? Hope so. 59.59 joules. That worked out great. Okay, so that worked out. Let's try the third problem right now. Okay, the third problem. So, 81,600 joules of heat energy is absorbed by 460.5 grams of copper metal. How much does the temperature increase? So let's do problem number 3. See if I can squeeze it in here. I probably can't. I'm not going to try. So I'm going to go blank page. All right, so problem number 3. Okay, let's take a look at problem number 3. So I'm going to start by writing the formula, the only formula that we care to use in this problem set. Okay, Q, the energy, equals its mass times the specific heat times how much the temperature changed. Okay, so let's take a look here. What do we got here? 81,600 joules of heat energy. Oh, so they give us 81,600 joules of heat energy. They've given us the heat energy here. All right, so this instantly is like, ooh, this is going to be a slightly trickier problem then, okay? It is absorbed by 460 grams. 460 grams is the mass. So they're giving us the mass here, okay? They're giving us the mass. All right. Now, what they don't give us the temperature increase. They ask it in problem 3. They ask us how much does the temperature increase. Okay, so we don't know the change in temperature. We have to find it. Okay, we have to find it. But we do know the specific heat because they tell us that this substance is made of copper. And so I'm going to go over here and I'm going to look. Copper has a specific heat of 0.385. All right. So 0.385. Let me use my color code that I've been using. 0.385 joules per gram degree Celsius. Okay. So this is algebra, guys. This is algebra. You can't just multiply all these things together because that's not how the equation is set up. We have to solve for temperature change, which means we've got to get the temperature change by itself. We have to, let's see here, it's being multiplied by 0.385, so we're going to have to divide both sides by 0.385. So let's see here. It cancels out over here. 81,600 divided by 0.385, and I get 211948. Okay, and that's equal to 460 grams times the change in temperature. Well, guess what, guys? We're still not done yet, okay? Because we have to get the temperature change by itself. This is algebra, all right? It's being multiplied by 460, so we have to divide both sides by 460 grams. Okay, so 211,948 divided by 460 Oh, does this work out? I get 460.7, and that's equal to the change in temperature. Let's see if that worked. Let me plug that in. 460, did I get that right? Oh my gosh, now that was pure coincidence that happened to work out that way, guys. What do you know? 460 Celsius, that was the change in temperature, all right? So the change in temperature was 460 degrees Celsius. Okay, guys, so this video has gone on a bit long. I'm going to stop it here. Okay, I'm going to stop this video here. This was problems 1 through 3. I'll make another short video where I do 4, 5, 6.